different because you're going to watch this video. Even though I'm in the live, I'm currently not at home, so I can't show you my screen. So with that said, what I want you to do is to pause this video for a moment and solve this question. Remember, when you're solving this, I want you to think about how you would highlight, what would you underline, because you always want to annotate or mark up your question so that you know what you're looking at. So pause this video now and solve this question. You may use a calculator. This is calculator active, so if you want to use the calculator, you may. Okay, so hopefully you solved this. So I'm going to show you how. So a restaurant orders hot dog buns and hamburger buns. The ratio of the number of hot dog buns to the number of hamburger buns is 2 to 3. So we have our hot dogs, our hot dog buns, and our hamburger buns. So I always like to kind of write this down. Hot dog, I'm just going to put a D there, is 2. We're comparing that to hamburgers. I'm just going to write ham. And that is 3. And that is our ratio. What is the ratio of the number of hamburger buns to the total number of buns? So this question is a little bit different. This total number of buns. So how many buns do we have all together? Well, we know the ratio of hot dogs to hamburgers. So now we need to find the total. Right? And that total, we're going to be looking at hamburger buns to the total. So we have hamburger buns right here, and we're going to be comparing that to the total. So hot dog buns are 2, hamburger buns are 3. The total number of buns together are hot dogs and hamburgers together, which is 3 plus 2, or 5. So our total number of buns is 5. Total number of hamburgers, 3. The biggest mistake I see on this question is people will put 5 to 3 instead of 3 to 5. You have to always keep it in order. If the question says, what is the ratio of the number of hamburger buns to the total number of buns, then you have to keep it in the order of hamburger to the total. Has to stay in the same order. You can't reverse them. So we have 3 to 5, which is B. The answer is B. So we are completing our lesson 5, unit 3. In Zern, you're going to be completing mission 3, lesson 5. If you are still on lesson 3 or 4, please complete those first. You cannot move on to lesson 5 until you have completed 3 and 4 on the Tower of Power. So today's learning targets are, we're going to learn about measurements and how they're expressed in different units. You can decide who is traveling faster or which item is the better deal by comparing how much for one of the same unit. At the end of this, I want you to understand that if two ratios have the same rate per one, they are equivalent ratios. So we're going to go through these quotients. Quotients always mean division. So as we go through this, I want you to try to solve them mentally, but you can also you write them down if you need to. But this is a lot of estimation, which means kind of guessing. So you need to determine, is this going to be close to 1/2, close to 1, or close to 1 1/2? So if you're going to divide 20 divided by 18, I want you to decide, is that 1/2, 1, or 1 1/2? You can hit pause and solve that. So when I'm dividing 20 by 18, I want to think about how many times will 18 go into 20? And it's going to be about 1. 18 is really close to 20. So I'm just going to say 1. I don't even need to solve this. I know it's not half because half of 20 is 10 and 18 is much more than half. I know it's not 1.5 because 18 is smaller than 20. We don't have a whole 1 yet. Now we have number 2. 9 divided by 20. So you have 9 things and you're dividing them out 20. Is this going to be 1/2, 1, or 1.5? 9 divided by 20. Pause and go ahead and solve that. So I know that 20 going into 9, it's not even able to go in a whole time, right? So it's less than 1. It's drastically less than 1. 1 is going to be much larger. So I know it's going to be this 1/2. And our last one, we have 7 divided by 5. 7 divided by 5. Pause and solve this. So I know that 5 can go into 7 at least a whole time. And then there's going to be a lot left over. There's going to be still 2 left over. And that's almost 1.5. So our answer here is 1.5. Okay, so today we're going to be talking about comparing distance and time. So some students did some treadmill workouts. Each one is running at a constant speed. This constant speed is something that you need to, whenever you see that, to think constant speed means you're going to be finding something like miles per hour or meters per second or meters per minute, and that finding that constant speed. So answer the questions about their workouts. So we're going to get to that in a second. Explain or show your reasoning. So the first thing we need to do is find a way to organize this information. Whenever you're looking at comparing things or answering questions or explaining, you need to be able to compare your work. So let's look. Tyler ran 4,200 meters in 30 minutes. Kyron ran 6,300 meters in half an hour. Y'all, half an hour is the same as 30 minutes. So minutes is kind of this common unit that I'm seeing here. Minutes. I can turn this into minutes really easy in minutes. So I know I'm going to be talking about distance compared to minutes. I ran 6.3 kilometers in 45 minutes. Now I see this kilometers a little bit different, but we still have meters. So we're going to have to convert, which we just learned about, convert kilometers into meters. Whenever you're comparing distance and time, or comparing the number of items for a cost, you have to have the same unit. So we have to have all minutes and we have to have all meters in this case. So we are still doing distance over time, or distance to time. So first we're going to do Tyler's. Let me erase that because that's just not doing what I want it to do. Alright. So I'm going to come to my yellow. We're going to do Tyler first. Yeah, it's hard for me to draw on this thing, so bear with me. So you always have to keep it the same. We're going to do distance and time. In this case, we're doing meters. I'm going to write an M here. And minutes. I'm going to put M-I-N. So meters and minutes. So we know that Tyler ran 4,200 meters in 30 minutes. Distance over time. Now, we can do things like find out, okay, for 1 hour, I want to find out how many meters he runs in an hour. That would be 60 minutes. So you can cross multiply, or you multiply 4,200 times 60 and divide that by 30, just like if we were to cross multiply. Whenever you're doing these ratio charts, cross multiplying seems to have helped a lot of you because you're comfortable with it. So we need to find our missing blank. So 4,200 times 60. You can use your calculator. That's fine. So go ahead and pause this and work this out for me. I'm going to pull out my calculator as well. All right, so I hope you worked it out. If you haven't, please make sure you do, because the practice is going to help you. So we have 4,200 times 60. Work that out. And then you're going to divide 252,000 is what I got. And we're going to divide that by 30. So that means Tyler runs 8,400 meters in 1 hour or in 60 minutes. But I also want to find out really what he runs in 1 minute. Because often we need to find that one, that per minute. How fast does he go per minute? So how would we figure that out? We're going to still use that cross multiplying using our original ratio, but guess what? You could also use this one, but we're going to use our original. So we have 4,200, and we're comparing that to 30 minutes, and then we're going to turn this. So this is set up just the same as our chart, right? 4,200, 30 minutes over the number we don't know, 1. So 4,200 times 1 is 4,200. And then you're going to divide that by 30. Pause and solve that. All right, so once you have solved that, you should have gotten 140. This 140 is how far he runs in meters, Tyler. In 1 minute, he runs 140 meters in 1 minute. Next up, we are going to change our color just to help us. And we're going to do Chiron. So, right here, Chiron. So I want you to pause and I want you to set up the chart yourself, because that practice is really helpful. Again, if distance over time. So go ahead and hit pause. All right, so hopefully you've hit pause and hopefully you've solved at least a couple of these. If you have not, follow along with me. So he ran his distance of 6,300 meters in 30 minutes or 1/2 of an hour. 30 minutes. So I know I need to really find that 1 meter. So we're just going to jump right to that. So 1 minute, not 1 meter. So cross multiply. If you see, this is set up the same as our fractions. You have 6,300 times 1, that's the cross multiplying, divided by 30. So go ahead and pause and fill that out if you have not yet. So 6,300 divided by 30 is 210. So Chiron runs 210 meters in 1 minute. Again, this is minutes. It's distance to time. Now let's do my time. I'm going to do hers in red. So here is my, right down here. Oh, you can't see the red very well. I'm going to do the white. So I want you to create your chart. I want you to have Mai's time in meters. So you have to convert this. Convert the 6.3 into meters and to 45 minutes. Go ahead and pause. Remember, distance to time. All right, so hopefully you pause and you solve this. So we know that my route runs 6.3 kilometers in 45 minutes. So I'm going to put the 45 here, but I need to turn this into meters. The reason it needs to be meters is because I need to compare the rate to Tyler and Kyron. Well, converting things sometimes gets a little confusing, and we just learned about this and went over it. But if you remember, King Henry died in space. King Henry died in space. Here's my space. Drinking chocolate milk. Hopefully you have heard this before, but King Henry died in space drinking chocolate milk. So our space is always our meters. This could be grams. This could be, centimeters. But in this case, it's meters. Meters is going to be here. So if we are at kilometers and we want to get to meters, how many spaces do we jump? We jump 1 space, 2 space, 3 space. So that's our decimal place. So 6.3 kilometers, we're going to go 1 space, 2 space, 3 space. So that means we need a 0 and a 0. So my is going to be, let me switch my color back. $6,300 meters, or 6,300 meters in 45 minutes. So that's our time, minutes. And then you need to find out how much does she run in 1 minute. So I'm going to draw my line. So now I need to find this 1 minute rate, because we need to have the rates all for that 1 minute, right? So go ahead and cross multiply and figure that out. Pause. So you're going to cross multiply by 6,300 times 1, which is 6,300, and you're going to divide that by 45. You may go, well, why do you keep telling us to still cross multiply? Because sometimes when you do this, you might want to find out 5 minutes or 20 minutes or 8 minutes. So then you'd have to multiply it by 8 or 5. So always cross multiply. So 6,300 times 1 divided by 45 is 140. So my runs 140 meters in 1 minute. Who else runs 140 meters in 1 minute? Pause and look around and see. So now we're going to take a look at our questions. So, what is the same about the workouts done? Tyler and Kyron. So, maybe it's Kyron. Kyron runs 210 meters in 1 minute. And Tyler runs 140 meters in 1 minute. So the rate isn't the same. What is the same? Well, they both run over half an hour or 30 minutes. So that would be the time. So time is the same. They ran the same amount of time. Now, what is a little bit different? So, Kyron ran faster. And I know that because Kyron ran much longer. He ran 210 meters. So he went much farther in 1 minute than Tyler. So he ran faster. So I would write Kyron's faster. I can't draw on this. But you get it. He's faster. This is not cooperating today. Now let's look at B. I want you to try this one on your own. What is same about the workout? So go ahead and hit pause. So what is the same about Chiron and Mai? Chiron ran at 6,300 meters in half an hour, and Mai ran 6,300 meters, and we know that because we converted it over here using King Henry Died in Space. Ran 6,300 meters, so they ran the same distance, but they had different times. So distance is the same. You see, they ran the same distance, but in different times. So who ran faster? Did Chiron or did Mai? So Chiron ran 210 meters in 1 minute, and Mai ran 140. I know it's hard to see this. So again, Chiron ran faster. So I'm just going to put that here. Try to write this again. So last is C, Mai and Tyler. So what is the same? What is different? Well, their rate is the same. They both ran 140 meters in 1 minute. So their rate, the rate, which is that 140 meters, so rate is the same for Mai and Tyler. So who ran faster? They ran the same speed. Now, what's different? Even though they ran the same speed, Mai ran farther and longer because she ran 6,300 meters, so she ran farther than Tyler, and she also ran for 45 minutes instead of 30. So Mai ran farther. This will not right. Yeah, so Mai ran farther. 2. At what rate did each of them run? Well, Mai and Tyler have the same rate. That rate is the distance over time using per or 1. So Tyler and Mai are both at 140 per minute or 1. You can write it multiple ways. You can write it as a fraction of 140 over 1. You can write it as 140 meters per minute. And Chiron ran 210. Meters per minute. So how far did Mai run in her first 30 minutes on the treadmill? Well, we know she ran 45 minutes total. And we know her rate is 140 times 1. Let me change my color here. Doesn't look so confusing. So we know that she has a rate of 140, that distance of 140, to time of 1 minute. And we want to compare that to, actually I'm going to put that over 1. $140 over 1, the distance over time. And we want to compare that for how long does she run in 30 minutes. So minute stays on the bottom, 30. So you're going to multiply how long she ran per minute by the number of minutes. So in this case, again, cross multiplying, 140 times 30. Go ahead and pause and solve that. So 140 times 30 is 4,200, or 4,200. So she ran 4,200 meters in her first 30 minutes. That's the same as Tyler. All right, so the next one that we're going to solve is talking about getting the best deal on beans. So when you are grocery shopping, oftentimes people think the more you buy, the more you save. If you buy that really big pack of toilet paper, then you're going to save more money. And while this is often true, it is not always true. It is, especially if you're comparing different brands. But we're going to talk about baked beans. And there's two ways to look at things. In this case, we might look at per can, but we're also going to look at per ounce. So you might want to say, okay, do I want a big jug of 50 ounces of soup, or do I want 10 ounces of soup? And you're going to compare the cost per ounce, not the cost per can. But this first one, we're going to talk about cost per can. So we have 4 different stores posted an ad for a special sale on 15-ounce cans. So they're all the same size. This is key. They have to be the same size if you're comparing per can. So 15-ounce cans of baked beans. So which store is offering the best deal? So which store should you buy from? Let's say you guys eat baked beans every day. Or you're doing a big cookout. So it doesn't matter how much you buy. You can buy 100 of them. So you need to figure out what is the best deal. So let's look at store number 1. Here, store number 1. Yay. Okay. So store number 1. Let's say that this is Aldi. I love to shop at Aldi because it is usually the best deal and the food tastes the same. So we have 8 for $6. So we get 8 cans of beans for $6. We're going to go, well, I want this 80-cent can over here. I don't want $6. But let's find out how much per can. So in this case, we're going to be doing the cost. So like earlier we did distance over time, but here when we're talking about price per item, we're doing cost compared to the number of items, or in this case, the cans. So we're going to set up our little T-chart, the cost, draw my line, per can. Okay, so we know we have 8 cans for $6. 8 cans for $6. What is next? We need to figure out how much 1 can is. You can cross multiply. Go ahead and work that out. So we're going to have 6 divided by 8, because we do 6 times 1 is 6 divided by 8. And that is going to give us 75 cents. Yes, you can put a decimal in here. That is okay. So each can cost us 75 cents for store number 1. All right, what's behind store number 2? Here's store number 2. All right, store number 2 is saying you can get 2 for $3. So again, we're going to make this little chart. 2 for $3. We have our cost compared to the can. The cost for this one is $3 for 2 cans. And we want to figure out how much is 1 can, that rate per 1. Well, 3 times 1 is 3, divided by 2. Pause and figure that out. And so it's going to be $1.50 per can. Well, you know what? I think I'd rather buy 75 cents per can, not $1.50 per can. So let's keep on going. Store number 3. What do you have to offer us, store number 3? This could be Food Lion or Walmart. I think this store number 2 right here is probably Harris Teeter or Walgreens if they're not running a sale. So we have our baked beans of 10 for 10. Well, that's super easy math. I know each can cost $1, right? But we're going to still make this little T-chart because I want you to always know that writing down your information is helpful. So we have our price per can. So the price is $10 for 10 cans. This is super easy math. So one can cost $1. And our last one, we're still going to make our little chart. Price per can, one can, is 80 cents. So who has the best deal? I'm going to buy my baked beans from store number 1. Store 1. And the reason is, and I'm not going to write all this out with this pen because it would take me a long time. The reason is store number 1 costs 75 cents per can. For one can, it is 75 cents. Store number 4 down here is the next best deal. So let's say maybe you don't eat a lot of beans and your mom asked you to, pick up some beans for something. You might get the 80-cent can because you don't need 8. And to get this deal, you have to buy 8 whole cans. And maybe you won't use 8 cans. So it's actually still better to buy the 80 cents. However, if you eat beans a lot, then you're going to want to spend the 75 cents per can. This adds up over time. Yes, it's only 5 cents per can, but if you do it often enough and with a lot of food, it can save you hundreds of dollars every year. All right, so question number 2. The last store, which is not any of these, so store number 5, has a sale, 28-ounce can of baked beans for $1.40. So remember I was talking about the 15-ounce size? We can't compare one can to one can anymore because the cans are different sizes. So let's talk about what to do. I'm going to change my color. I'm going to go with blue. All right, so here what we need to look at is the price per ounce. So we're still going to do this price, except for now we're going to do it per ounce. Symbol for ounce is OZ. Ounce. Price per ounce. So we know, I'm going to start with our cheapest, our best deal. Because if I know how store number 5, 28-ounce can compares to my 75 cents per can, then I can make some decisions. So the price here is going to be 75 cents for one can or 15 ounces because one can equals 15 ounces. So this 1 that we had over here is now 15. That's important. You can't put a 1 here because then your numbers are going to be wrong. You have to do it for ounces. So you have to convert the single can to how many ounces is one can, and that's 15. All right. And we want to find out how much does it cost per ounce for that 1. So cross multiply 0.75 times 1 divided by 15. And you're going to get 0.05. That means 5 cents per ounce. So for every ounce, you pay 5 cents. So now let's compare this to our 28 ounce. So again, we're going to do price to ounces. Our price is $1.40. But we don't get 15 ounces, we get 28 ounces. And then we need to find that per 1 ounce. What is our rate? So go ahead and pause this and cross multiply. 1.40, $1.40 times 1 divided by 28. And what do you get? Go ahead and hit pause. I want you to try this on your end, please. So 1.40 times 1 is $1.40, 1.40. And then dividing that by 28, you get 0.05. Now, let's say you messed up your math and you got like, let's say you multiplied it. So you did 1.4 times 28. That's like 400 something. Would it cost $400 per ounce? No. So then you know you did something wrong, so you can fix it. But let's look. Per ounce, store number 1 over here cost 0.05 or 5 cents per ounce. And our 28 cans of baked beans also cost 5 cents per ounce. So they're the same as store number 1, right? It is a better deal than store number 3, 4, and 2, or 2, 3, and 4, however you want to do it. So these two are equal in deal. So you might want to decide, well, maybe there's some things at this last store that are a better deal, so I'm going to buy the 28 ounce. Or maybe there's better deals over here at Aldi in our store number 1, so we're going to shop there. So it doesn't matter which cans you buy. If you buy 8 for $6 or if you buy 28 ounce can for $1.40. Now again, like we talked about earlier, this might be your better option because you only have to get 1 can. You don't have to get 8. And so you're only spending $1.40 instead of $6. So different things to think about. So just to kind of summarize what we're talking about is we are looking at how we're looking at a rate and we need to find it per one. So in our first example, we had Tyler, Kieran, and Mia, or Mai, and we compared the rate per one, the meters, the distance over time, or meters per minute in this case. Instead of meters per second, we had meters per minute. Then we compared our price per can. So we had per 1 can, 75 cents per can for store number 1. Store number 2, or the 10 cans for $10, $1 per can. 3 was 2 cans for $3, or $1.50 per can. We don't want to shop there. That's too much. 80 cents per can for our last deal at store number 4. If you remember, we also had store number 5, which was per ounce, right? It was 5 cents per ounce, which was the same as the store number 1. So you can compare things per can or per ounce in some cases. So what do you prefer? Do you think you like to compare it per one? Does that make it easier? I always find it makes it easier for me to find the per 1 unit. When you see that word per, it means 1. If something is asking you per, it means 1, such as per hour, 1 hour. If I'm going 50 miles per hour, that's not 2 hours or 3 hours, that's 1 hour. 50 miles per 1 hour. So that word per means 1. If I buy 5 movie tickets for $50, each movie ticket would be $10. So it would be $10 per ticket. So if I bought a bunch of tickets and I was selling them, I'd say it's $10 per ticket. So if you want 1 ticket, it's $10. If you want 2 tickets, it's $20 because per ticket. Per means 1. All right, so you are going to complete your exit ticket. I suggest you do the exit ticket after you do Zern. So if you have not done Zern, I want you to go do that now and make sure that you are getting through all the Tower of Power for this lesson, and this is lesson 5. So you should have completed this week lesson 3, lesson 4, lesson 5. So go work on that now, and I'm here for questions. When you get back to your cooldown, you can hit pause on this video and come back, and I'm going to kind of help you get started on this. I will not solve it for you, but I will tell you that going through Zern, you should get the answer or get help getting the answer for this. So bottles of sparkling water. So you've done Zern, you've come back. Bottles of sparkling water usually cost $1.69 each. So I know we're talking about water and the costs. So something about cost. This week they're on sale for 4 for $5. You bought one last week and one this week. Did you pay more or less for the bottle this week? How much more? So we need to figure out, what is the better deal, last week or this week? So let's start with this week. This week, they are on sale for 4 for $5. So we always have the cost and the item. In this case, the water bottle. I'm just going to put a W. So the cost for the number of water bottles. So we can get 4 water bottles for $5. One of the biggest mistakes I see right here is you put the 5 here and the 4 here, and that messes up the math. Always make sure that the dollar sign is with the dollar sign. 5, 5, right? All right, so then we need to find per. Always find per. Not like purring like a cat, but per equals 1. So 5 times 1 is 5 divided by 4. Go ahead and pause and work that out. I'm not giving you the answer. Then you're going to set up last on your own. Again, remember, price per water bottle. And now that's where I'm going to stop. Make sure that you are answering. Did you pay more or less for the bottle this week? So comparing this week to last week. Which week was better? Which one did you pay more for? How much was more or less? Include your answer to these questions in your response for your cool down. You have to submit your cool down for your grade. Make sure you complete Zern and then come complete this cool down. All right, I hope you all have a great week. Let me know if you have any questions.